Hi everyone, I'm Cassidy Soloff. I work with Armin at the University of Arizona. And I'm going to talk about the analysis I've been working on the 8 transit flights between Virginia and Langley, or between Langley and Bermuda. So the motivation behind this study is the fact that there's a rich history of studies that look just off the coast of the US and around Bermuda, but there's few studies that bridge these two regions. So out of Activate's 179 flights, 8 of these were transits between Virginia and Bermuda, and we want to use these flights to fill that gap. So the key questions we wanted to look at were how do aerosols and trace gases vary with offshore distance? And then we wanted to compare the free troposphere measurements with the boundary layer measurements to see if there's any differences between those two regions. So starting off with just the flight tracks, these are the 8 transits, and highlighted in purple is a day with high accumulated precipitation along the trajectory, and that's what all these flight tracks are colored by. And we calculated this by taking the high split modeling, 3-day back trajectories, and summing all the precipitation. And then just looking at that, we saw that these 2 flights that occurred on May 18th had the highest precipitation. So that will tie into some of the results we'll see um, in the future in this presentation. So these are the actual high split back trajectories, 3 days. And the first 2 flights, we can see the flight track followed very well with the continental outflow we were seeing. So we called these the golden flights. For the other flights, there was some mixture of continental outflow and marine influence. So we used the golden flights to look at the clearest trends, and then we compared it with the other flights to see the differences. So here are the HSRL2 light curtains for the golden flights. The top one is the morning flight. The bottom one is the afternoon flight. The interesting thing in this picture is the distinct aerosol layer aloft, and you can see it thickens by the afternoon flight on the way back. And the other thing that's worth noting is near the coast, we have a very shallow boundary layer that gets much deeper as you go over the marine environment. Okay, moving on to trace gases. So this is methane and CO, and we can see there's a clear offshore reduction in in both these two gases concentrations with distance. The top is methane and the bottom is CO. And then we can see that in the free troposphere and boundary layers, this trend exists, but it's stronger within the boundary layer. And these are just for the golden flights. Here, we can see the axis is flipped because this is just the way back. So we would expect them to be mirror images of each other if there's a similar trend in the morning and afternoon flights. Oops. So this is all the data, and then we can see that there is still a pretty strong gradient within the boundary layer, and the free troposphere has less of a strong gradient. And we use this CO concentration measurement as a good tracer for continental outflow because it has sufficient lifetimes and continental sources. So we'll see that tie into some of the future results as well. And then the other thing that's worth noting is you can see the concentrations in the golden flights level off around 900 kilometers. So that's a important thing to note when you're trying to see when you can consider something a pristine marine environment and when you would expect there to still be continental influences. Now looking at SMPS data, we can see the number concentration for particles less than 100 nanometers, and we can see a similar reduction in concentration with offshore distance, both in the free troposphere and the boundary layer. For LAS measurements shown here, there was a less prominent reduction in the boundary layer and no clear trend in the free troposphere. The other thing that's interesting is this day in purple is the day I mentioned that had high APT values. So this air mass saw precipitation before it reached the aircraft for measurement. So the concentrations are slightly lower in the boundary layer for this flight day. So that might indicate that there was removal of these larger particles due to precipitation. Now, these are size distributions within the boundary layer for the 8 flights. I bin the data into these 4 size ranges of distance from Langley, and then I fit a 2-mode log normal distribution. And then this plot here summarizes the results for each flight day. Note that the last 2 flights occurred on different days because that's when the aircraft was stationed in Bermuda. So the trends we saw were the golden flights showed a decrease in the Atkin mode number concentration and geometric mean diameter with offshore distance. And for looking across flights, the Atkin mode generally showed this trend for 4 of the 5 days. And the Atkin mode mean geometric diameter also showed this trend for 3 of the 5 days. Meanwhile, the accumulation mode did not show a clear trend in both the number and geometric mean diameter, and neither did sigma for these model fits. And across the board in the free troposphere, the size distributions didn't show a clear trend with offshore distance. Now we wanted to look at new particle formation, so we use this ratio of number of particles greater than 3 nanometers to number concentration greater than 10 nanometers to see if this number is larger, there would be more particles between this 3 and 10 nanometer range. But note that this does not mean the new particle formation occurred at the site of the measurement. It just means that it occurred at some point prior to the measurement. The interesting result is that the median values of this ratio were relatively consistent with offshore distance and generally higher in the free troposphere. Okay, moving on to aerosol composition using AMS mass. We can see that in the boundary layer, there was a reduction in the organic mass that we see here in green and an increase in the sulfates. And unfortunately for the way back, the Golden Flight, the AMS instrument did not collect data for most of the flight. But we generally see this trend just more weakly for the other flights. And the other thing to note is that there is no clear trend in the free troposphere. The total mass is plotted in black here, so you can also see there's generally a decrease in the total AMS mass measured with offshore distance. Now, looking further at the total AMS mass and relating it to CO concentrations, I use the delta CO measurement to trace continental outflow, which is just by subtracting each CO concentration and subtracting that, or the 5th percentile of all the CO concentrations in the boundary layer from that value to get a delta CO value. So if we have a lower delta CO, then we're looking at more pristine air that is further away from the continent typically, and the points here are colored by distance from Langley. So for the Golden Flight, we can see that the relationship is nearly 1-to-1 or linear for the delta CO versus the total AMS mass. So that means that we're just looking at dilution of that of the continental AMS mass as you go offshore. And then interestingly for this second panel here, which is the 2 flights that had those high APT values, you can see that near the coast in red, the AMS mass was much lower, and then we saw a slight increase as you get to Bermuda. So this is more evidence of potential removal of mass from precipitation. And then here, this could be a result of the air mass shifting, like we saw in the high split modeling, to more marine influences, which might have enhanced the mass. And then the other flights where the flight track did not follow the outflow nearly as well, the results are more scattered. Now looking at hygroscopicity, we can see F of RH increase with a decrease in organic mass fraction, which we would expect because organics are less hygroscopic than sulfates, and the sulfate mass was increasing as the organic mass was decreasing, mass fraction, I mean. And the trend was stronger within the boundary layer, as you can see here, but comparing the top and bottom. Now looking at a specific type of organics using F44, which is the relative amount of carboxylic acid contributing to the total mass. We can use this and divide it by organic mass fraction because you need to keep organic mass fraction fixed to compare F44 between different measurements. We can see that as F44 increased per fixed organic mass fraction, the F of our H value also increased. And this makes sense because the carboxylic acids contain more hydroscopic organic mass that's more highly oxidized. So this would tie into creating more hydroscopic aerosols. And once again, in the free troposphere, the trends are less clear. Okay, so this is a summary of all the conclusions I saw where we saw offshore gradients, where we didn't see clear trends. And I'll be happy to take questions now or after. I also have a poster over there so we can discuss it in more detail later on.
Thanks, Cassidy. Any burning questions? Again, as you said, the poster's here, so we can have all the extended discussion you'd want tomorrow formally. So, okay, so we are right at lunchtime now. So according to the program, we will start up again here with a virtual presentation at 1:30. You're welcome to leave anything you want here. I will be here. Okay, so we'll see you at 1:30. Eating options, if you're new here, the street just to the west called Park.